Video about percent yield. Percent yield is a concept that we're going to do and calculate both on paper and in lab. So before we can begin that, let's talk about two words, two important vocabulary words, and that is theoretical and actual. So theoretical yield is the amount of product calculated for, meaning if I react things together, how much of the product will I make? That's the theoretical yield. And if theoretically everything goes right in lab, that's the amount you should get, okay? Then there's actual yield. Now you actually take this, go into lab and perform it. And when you come out, that amount is called your actual yield. Theoretically, maybe you should yield some number, but in lab, sometimes things go wrong, so you actually get something else, okay? Now, another way to think of it is, let's say you want to go to your friend's house. And this is a new friend, so you Google MapQuest it, and it says that it's going to take you 15 minutes to get there. That's your theoretical. Theoretically, if everything goes right on the road, it should take you 15 minutes. That's the amount that you theoretically should take to get there. Now, you get in your car, and you realize there's all this snow on the street. So it's taking you forever to drive. And then you hit every red light. And there's an accident, so now it's taking you so much longer. Finally, when you clear the accident, you get to your friend's house and 25 minutes have passed. That's the actual yield. It actually took you 25 minutes because of all the accidents and the things you came up across when you did it. Theoretically, it should have taken you 15, but it actually took you 20. So that's what we're looking at. Theoretically in lab, you should get 5 grams, but you dropped a little, and so you only got 3 grams in lab. When we compare these two, we can get what's called a percent yield. Percent yield takes your actual and compares it, divides it by your theoretical, times it by 100 to get your yield. Okay? Let's take a look at our chemistry example. For us, percent yield, we're going to begin with a limiting reactant problem. So let's take a look at one I've done for you. And that is nitrogen and hydrogen are going to react together to make NH3, which is ammonia. And I'm starting off with 4 grams of N2 and 4 moles of N2 and 6 moles of H2. And I'm going to mix them together. And the first part, I want to know theoretically how much NH3 am I going to make in this lab? Well, on paper here, this many moles gives me this much product. This many moles gets me this much product. We know from limiting reactant that I'm going to be making this much of NH3. I can't make that because my 6 moles of H2 limits me, so I only can make that much. That's my theoretical. How much I really am going to make in lab. And if all goes well, I should make 4 moles, right? If all goes well, it should take you 15 minutes to get to your friend's house. Now, you go into lab, you take your 6 moles of H2, you react it with 4 moles of N2, and some little accidents maybe happen, or some spills, or some conditions you can't, control. So how much do you get then? All right. Well, if you remember in lab, it's important for us, let's bring this back, to get things in grams because we have balances. So while 4 moles of NH3 is good, well, it would be better if I could have that in a gram value so I can work with it a little bit. So really quickly, why don't we convert 4 moles of NH3 to grams of NH3? So I did that for you here. I just took my 4 moles of NH3 and converted it into grams of NH3. So now, 68 grams. That's good. That makes a little bit more sense for me in lab. In lab, theoretically, if everything goes well, I should get 68 grams of NH3. Okay, so I go in lab and I do this. Now, it's great if we're in lab because we can actually do it. But what if we're not in lab? What would a problem look like? Well, here's an example of a problem or information I have to give you if we're not in lab. I have to tell you what happened in lab. And in lab, it says if 64 grams of NH3 is actually produced in lab, what's the percent yield? Okay, again, I have to give you that because you're not in lab right now, sitting at home watching this video. So, let's take our equation and put our actual 64 grams of NH3 over our theoretical According to my calculation, I theoretically should have produced 68 grams of NH3. Divide those two, multiply by 100, and you get your answer. Don't forget 2 sig figs here, 2 sig figs here, no sig figs on the 100, so my answer should have 2 sig figs and a percent sign. So go ahead and divide those two and get an answer. Pull out your calculator. This is your part to do. You know, just looking at this, I wasn't too far off. 68 grams is what I should have made, and in lab I made 64. Can think of some errors, maybe like if I was using a crucible or something, the lid maybe came off and some of my gas escaped, right? Some things like that could have happened, right? Where did my extra mass go? So this isn't a bad yield. It's pretty good yield. So that's how you calculate for percent yield.